So this video is all about looking at rationalizing the denominator. Basically what that means is that we're not allowed to leave the denominator with a surd. So we have to convert it into a whole number by what we say is rationalizing the denominator. Now this is like a math convention, so if you're ever looking in the back of the textbook and your answer was 1 on root 2 and the answer in the back of the textbook was root 2 on 2, that's why. They don't like to have surds on the bottom of a fraction. So it's just a normal thing. Right, so some people I guess believe that fractions are easier to work with if the denominator is a rational number, not a surd. So we rationalize surds by multiplying by the same surd because they'll cancel each other out. Right? For example, root a times root a would be the same as the square root of a squared. So the square and the square root cancels each other out and we get a. So a normal number. But like changing any denominator, you have to multiply the top and the bottom by that same number. So let's look at an example then. Here we have 4 on root 2. Now if we want to make 4 on root 2 into a rational denominator, we're going to have to multiply by root 2 on the bottom because root 2 times root 2 is 2. But if we multiply the bottom by root 2, we need to multiply the top by root 2. So we're actually just multiplying by 1 because root 2 divided by root 2 is the same as 1. So we're not actually changing the maths here. So then we're just going to simplify that out. We have on the top 4 times root 2 and on the bottom root 2 times root 2, which we know is the same as root 2, the square root of 2 squared, which is the same as 2. So we've rationalized the denominator. Okay, we have a whole number on the bottom of the fraction. So when does this get a little bit more difficult? Well, that's when the bottom isn't just a simple square root. For example, we could have 1 plus root 3 on the bottom. So we can't multiply by root 3 in this instance because of that plus and the 1. So what we need to do is we need to think about some maths that might bring this back to being a whole number. And you have the perfect expansion, and that's called difference of squares. So that's where you had a plus b multiplied by a take b. And you ended up with an answer of a squared take b squared, and that's going to get us a whole number. So when it looks like this, what we're going to multiply by is the same denominator but with a different sign. So in this case it was 1 plus root 3, and now we're going to multiply it by 1 take root 3 on 1 take root 3. So we're still multiplying by 1. Okay, and we go back up and look, here is our difference of two squares rules. Remember that when we have a plus b times a take b, we end up with a squared take b squared. So a squared would be 1 and b squared would be root 3 times root 3. Root 3 squared, which is the same as 3. So we're going to end up with a base number being a whole number or rational number. So the top just comes 2 times the 1 take root 3. The bottom becomes 1 times 1, so the a squared, and root 3 times root 3, which is the b squared. We know that root 3 times root 3 is the same as 3, so we can simplify that down. We can expand out the top by multiplying everything inside by the 2. Some teachers will say you can leave it like that. That's fine. Make sure you ask your teacher that one. And then we need to simplify the bottom. So it's the minus 2. Now there's an issue here as well, I suppose. Some people say you shouldn't have a negative on the bottom either, and to get rid of that. But that's not me. So carry on, I guess. Now let's just have a quick look at this one here, this h, because it's another example of something slightly different. Like these all have, a normal square root on the bottom, but this one has a 7 and a root 3. So you might be thinking, oh, I have to do something kind of crazy, but that's not the case. All we need to do is get rid of this root 3. So when we think about it, we're going to multiply, just like we said before, the top and the bottom by the root 3. So our top then will become 6 root 5 by root 3, and our bottom will become 7 root 3 by root 3. Now if we want to simplify this, remember our product rule is that we can do the 6 and we can do the product of 5 by 3 underneath the same surd there, and we can do the bottom. Remember, root 3 times root 3 is the same as 3, and 3 times 7 would be 21. There you have it. We've rationalized the denominator.